In this video, the learner will simplify a radical expression to its simplest form. So first we need to go over what a radical expression is. This root symbol is called a radical, and a radical is any quantity with a radical symbol. So we have this radical expression here, where this 4 is the coefficient. It is the number usually in front or being multiplied by our radical, and the radicand is the number underneath the radical. First, we're going to consider the square root of 25. Because of the way this radical expression is written, it means the positive square root of 25. In order to evaluate that expression, we need to ask ourselves, what number multiplied by itself equals positive 25? And we know that it has to be positive 5. Because we are interpreting this to say the positive square root of 25, we won't consider the negative 5 as our solution to that evaluation. Okay, we need to evaluate these radical expressions. Square root of 49 should be 7. Square root of 100 should be 10. Square root of 1 should be positive 1. Notice number 4 here has a negative symbol out front. We're going to be looking at the negative square root of 144 here, which means we have negative 12. And the square root of 0 is 0. Notice each one of these evaluations ended up being an integer. Think about why those answers came out to be integers. What about something like the square root of 8? Would that come out to be an integer? We know that 8 is not a perfect square, so therefore it cannot be an integer when it's evaluated. So how would we simplify that, if at all? Well, in order to simplify that, we're going to need to understand some properties about radicals. So that first property is going to be the product property, where if we have the square root of a times b, we can actually break that apart into the square root of a times the square root of b, as long as a and b are positive. If they're negative, then we're getting into imaginary numbers, and we're not quite there yet. If there are coefficients in front of those radicals, we're going to consider the rule outside times outside and inside times inside, which mathematically looks like a root b times c root d. We would multiply the coefficients together and they would remain a coefficient. And we would multiply the radicands together and they would remain a radicand. So here we have the square root of 15. We could break that apart into factors. We could have square root of 1 times the square root of 15. We could also have the square root of 3 times the square root of 5. Square root of 26 could be broken down into the square root of 2 times the square root of 13. It could also be written the other way, square root of 13 times the square root of 2. Here we're going the other direction. Here we're multiplying those two things. So notice we have coefficients to each one of those radical expressions. So we're going to multiply those coefficients together and multiply those radicands together. So 2 times 4 becomes 8. 3 times 6 becomes 18. Now we can consider this square root of 18 here, and I would say that this one needs to be simplified further. And we'll talk about why the square root of 18 needs to be simplified further next. So consider the factors of 18. What do you notice about any of those factors? Hopefully, because we're talking about square roots, you've noticed something about that number 9. That 9 is a perfect square. Well, if we're going to use the product property to help simplify the square root of 18, we could break that apart to be the square root of 9 times the square root of 2. But we know the square root of 9 is actually 3, so we could replace or substitute the square root of 9 with 3. So we could say that the square root of 18 simplifies to be 3 square roots of 2. You can take a second to plug these into your calculator and see that 3 square roots of 2 is equivalent to the square root of 18. Their values are the same. So we're not changing the value of that square root, we're only changing what it looks like. We're putting it in its simplest form. Now, before we had a coefficient of 8 in front of that, let's look at how we would simplify with that coefficient. We would start with 8 root 18. The 8 is not what's being simplified, it is only the root 18. So we would still have 8 as our coefficient and break up that 9 and 2 from our 18. The square root of 9 still becomes 3, but now that 3 is a coefficient of that square root, which needs to be multiplied by the coefficient that we already had in front of that radical to begin with. So 8 times 3 is 24 root 2. If you were to plug 8 root 18 into your calculator and 24 root 2 into your calculator, they will have equivalent values. They will have the same numerical value. Okay, of course there are other ways to break up that radical. For example, 8 root 18 could be 8 root 6 times root 3. I want you to consider, though, why does breaking up the expression in this way not help us simplify our expression? Next, we're going to simplify some radical expressions. We're going to simplify the square root of 12 if possible. Just like we considered with the 18, we're going to consider the factors of 12. Well, the factors of 12 are 1, 2, 3, 4, 6, and 12. I'm going to choose the 3 and the 4 with the product property of radicals. So we have the square root of 3 times the square root of 4, and we understand that the square root of 4 becomes 2. So the square root of 4 is 2, and we have the root 3 that can't be simplified further. I want you to try these 3 radical expressions using that product property of radicals. See if you can break them down to their simplest form. I have 2 radical expressions here that I want you to use the product property of radicals to simplify. We have 9 root 2 times 5 root 6, 4 root 3 times 5 root 6 times 2 root 2.